Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of parallel data transmission and the serial data transmission in 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of RS-232 standards used in the 8051 microcontroller. Okay, let's start our today's topic. First of all, we have to know or we have to see the most important characteristic of the serial communication named as the baud rate. The baud rate is used to measure the speed of transmission. It is described as the number of bits passing in 1 second. For example, if the baud rate is 200, then 200 bits per second passed. In telephone lines, the baud rates will be 14,400, 28,800 and 33,600. That means the baud rate is the defined as the speed of transmission, that means the number of bits per second. This ratio gives us the value of baud rate. If there are 200 bits in second, then we can say that the baud rate is of 200 second. Okay, I hope you all understand the concept of baud rate here. Now let's start our today's topic. What is RS-232 standard? The RS-232, that means recommended standard 232, is a standard protocol and used for serial communication. It is used for connecting computer and its peripheral device to allow serial data exchange between them. That means if we want to interface our 8051 microcontroller with the PC, then we require here the RS-232 standard. Okay, we cannot connect directly 8051 microcontroller with the PC. Okay, here in between them we have to use the RS-232 standard. Okay, as it obtains the voltage level for the path used for data exchange between the devices. It is used in serial communication up to 50 feet with the rate of 1.492 kilobits per second. That means the RS-232 standards can be used from the distance or up to distance 50 feet. Okay, this is the range of the RS-232 standard without loss. As EIA defines, the RS-232 is used for connecting data transmission equipment, that is DTE, and data communication equipment, that is DCE. That means RS-232 is used to connect between DTE and DCE. Here we can see that the transmitting line of the DTE is connected with the receiving line of DCE, while the transmitting line of the DCE is connected with the receiving line of the DTE. Okay, and the ground of both DTE and DCE is common together. This is the main important part of this connection, that the ground of the both terminal should be same. Okay, now universal asynchronous data receiver and transmitter, that is UART, used in connection with RS-232 for transferring data between printer and computer. The microcontrollers are not able to handle such kind of voltage levels, hence connectors are connected between RS-232 signals. That means RS-232 signals can be connected directly in the case of such as PC to the printer. Okay, that means we can directly connect them through the RS-232 standard, but we cannot use or we cannot connect the PC to microcontroller. We have to use some connector between them, and these connectors are named as DB9 connector or DB25 connector. Okay, these connectors are known as the DB9 connector or DB25 connector as a serial port, and they are of types male connector DTE and female connector DCE. This is the diagram of the female connector DB9 and the male connector DB9. DB9, 9 stands for 9 pins. Okay, and the 9 pins are such as the DCD, RD, TD, DTR, SG, DSR, RTS, CTS, and RI. What are the meaning of these words? Let's see. Pin description of the DB9 connector. The pin number first is CD, that means carrier detect, and its function is incoming signal from DCE. The second pin is RD, that means receive data. Its description is receives incoming data from DTE. The third pin is TD, that means transmits data, and its description is send outgoing data to DCE. The fourth pin is DTR, that means data terminal ready, and its description is the outgoing handshaking signal. The fifth pin is ground, and we know that the ground is the common reference level. The sixth pin is DSR, that means data set ready, that means it is incoming handshaking signal. The seventh pin is RTS, that means request to send. Its description is outgoing signal for controlling flow. The eighth pin is CTS, that means clear to send, that means incoming signal for controlling flow. And the last pin, ninth pin is RI, ring indicator, that means incoming signal from DCE. These are the pins of the DB9 connector. Okay, now let's see the pin description of DB25 connector. Similar, in case of DB9 connector there are 9 pins. In case of DB25 connector there are 25 pins, and these connectors are available in both male and female part. Okay, the pin description is that this is the pin number 1, pin number 2, pin number 3 up to pin number 30. This is pin number 14, 15 up to pin number 25. Okay, and the pins are the protective ground, transmit data line, receive data line, request to send, clear to send, data set ready, signal ground, data carrier detect, reserved, unassigned, secondary DCD, secondary CTS, secondary T cross D, that means secondary transmitting line, transmit clock, secondary receiving line, receiver clock, local loop back, secondary RTS, data terminal ready, that means DTR, remote loop back, ring indicator RI, data rate detect, transmit clock, and test mode. These are the pins of DB25 connector. Now let's see the main concept here, how RS-232 communication works. The working of RS-232 can be understood by the protocol format, and this protocol format is shown in this diagram. As RS-232 is a point-to-point asynchronous communication protocol, it sends data in a single direction. That means here we remember that in asynchronous data communication we use the start bit and stop bit along with the data. Here no clock is required for synchronizing the transmitter and receiver. The data format is initiated with start bit followed by 7-bit binary data, parity bit, and stop bit, which are sent one after another. That means here we can see that the start bit is always 0. We know that. Then the 7-bit data, that means the 7-bit ASCII character, then parity bit for the correction of the data or checking whether the noise is introduced in the data or not, and then the two stop bits. Okay, this is the protocol format of the RS-232 communication. Okay, now let's see. The transmission begins with standing start bit 0. Okay, this is succeeded by 7-bit ASCII data. That means this is the 7-bit ASCII code 00000001. This is the ASCII code for the character A. Then the parity bit is appended. This is the parity bit. This data for the receiver validation. The data sent from the transmitter should match the receiver. Finally, the transmission is halted, that means stopped, by using a stop bits, and it is represented by binary 1. These are the stop bits. Generally, 1 or 2 stop bits can be sent. Here, the 2 stop bits are sent. Okay, that means this is the start bit. This is the 7-bit ASCII code for A. This is the parity bit, and these two are the stop bits. This is the protocol for the RS-232 transmission. The RS-232 transmission, for its proper working, it requires some handshaking signals. There are many of the pins of the RS-232 connector are used for handshaking signals, such as the DTR, that means data terminal ready, DSR, data set ready, RTS, request to send, CTS, clear to send, DCD, carrier detect or data carrier detect, and RI, ring indicator. These are the handshaking signals used by the RS-232 standard. Okay. Now let's see the data transmission and reception using RS-232C. Modems and other devices used to send serial data called as TCE, that is data communication equipment. Okay, that means these are the data communication equipments, also known as the modem. The components that transfer or receive serial data are called as DTE, that is data terminal equipments. These are the data terminal equipments. The signals and handshake signals are transferred between DTE and DC, that means from DTE to modem, from DTE to modem. The signals and handshaking signals are transferred to synchronize or to operate with each other. Okay, this is the basic data transmission and reception process in RS-232 standard. Now let's see the important topic here, the 8051 connection with the RS-232. We know that the RS-232 has two pins, namely R cross D and T cross D pins, which are used for transferring and receiving data serially. In the pin diagram of 8051 microcontroller, we seen there are two pins for transmission data known as T cross D and for reception of data named as R cross D. T cross D and R cross D are the part of port 3, port P3.0 and for pin P3.1. Pin 11, that means P3.1 of 8051 is assigned to T cross D, while pin 10 P3.0 is of 8051 is designated as the R cross D. These pins are TTL compatible. This is the most important statement here, that the R cross D and T cross D pins are TTL compatible. TTL means transistor logic compatible. Okay, hence it requires a line driver to make them RS-232 compatible. The driver is used for this is MAX232 chip. That means here the T cross D and R cross D, these two pins are TTL compatible. To make it compatible with RS-232, we use a line driver chip named as MAX232. Okay. Now let's see details about the MAX232 chip. The MAX232 converts from RS-232 voltage levels to TTL voltage levels that are acceptable to 8051. It uses plus 5 volt power source, same as the source voltage of 8051 microcontroller. This is the main advantage of the MAX 232 chip that it requires the plus 5 volt power supply, because the power supply of the 8051 microcontroller is also the plus 5 volt. Okay, hence no dual power supplies are needed. MAX 232 has two sets of line drivers for transferring and receiving data. That means MAX 232 has two sets of line drivers for transmitting and receiving data. Line drivers used for transmitting, that means T cross D, called as T1 and T2. Okay, the line drivers used for R cross D designated as R1 and R2. T1 and R1 are used together for T cross D and R cross D or the 8051. The second is left unused. That means in first we can use T cross D and R cross D, and the second is left unused. It requires 4 capacitors ranging from 1 to 22 microfarad. That means here are it requires 4 capacitors whose values ranging from 1 microfarad to 22 microfarad. This is the basic interfacing diagram of MAX 232 with 8051 in null modem. Here we can see here that 8051 microcontroller is connected with the RS232 standard, that means DB9 connector, through the MAX 232 chip. Okay. Here we know that the pin number 11 of 8051 microcontroller is T cross D, and pin number 10 of 8051 microcontroller is R cross D, and the pin number 11 of MAX 232 is T in, while the pin number 12 of R cross D MAX 232 is R out. These are connected with each other, and the output, that means T1 out, is connected with the second pin of DB9, and 13 number pin is connected with the third pin of DB9. These are the interfacing connection of MAX 232 with the 8051 microcontroller. This is the another diagram of in which we can see here the detailed view. That means the P3.1 T cross D is connected with T in, and T1 out is connected with the second number pin of the DB9. Here the R cross D is connected with the R out, and this is connected with R in with the third number of DB9. Here this side, that means the 8051 side, is the TTL compatible, and this side is RS232 compatible, and this is the basic job of this MAX 232, that it makes TTL compatible with the RS232 compatible. Okay, I hope you all understand why we use MAX 232 chip here. Okay, now let's see RS232 features and specification. The first one is RS232 uses asynchronous communication, so no clock is shared between PC and the modem. We know that RS232 is used for asynchronous data transmission, and for asynchronous data transmission we do not require the synchronization between transmitter and the receiver. That means the transmitter and receiver should not be synchronized with each other. Hence there is no clock is shared between transmitter and the receiver, that means PC and the modem. Logic 1 on pin is stated by the voltage range minus 15 volt to minus 3 volt, and the logic 0 on pin is stated by the voltage range plus 3 volt to 15 volt. The logic has the wide range of giving convenience for the user. That means in RS232 the logic 1 stands for minus 15 volt to minus 3 volt, and the logic 0 stands for plus 3 volt to plus 15 volt. That means we get here a wide range of operating voltage. The third feature is that MAX 232 IC can be installed easily to establish RS232 interface with the microcontroller. Fourth one is full duplex interface of RS232 is very convenient 2-pin simplex RS-232 interface can also be established easily if required. The next specification is that a maximum data transfer speed of 19 kbps is possible through RS-232. The next one is a maximum current of 500 milliampere can be drawn from the pins of RS-232, and the last one is the interface can be established up to a distance of 15 feet. Okay, these are the features and specification of the RS-232 standard. Let's see the disadvantages of RS-232 standard. There is no pin dedicated for powering device, that means no VCC pin is available. The more connection pins are required in RS-232 standards, switching voltage between plus 15 volt and minus 15 volt is difficult at higher speed, a maximum speed of 19 kbps, and it is very slow. A maximum distance for is a 15 feet. Above 15 feet distance we cannot use the RS-232 standards. It gives some amount of noise if we use the distance greater than 15 feet. 50 feet. More pins in RS-232 standards are used, hence it leads to higher noise. Only a single device can be connected to RS-232 connector, unlike I2C. And the last disadvantage is that it needs a hardware to convert high voltage logic of RS-232 to be compatible to TTL. That means it requires the line drivers like MAX232. This is the disadvantage of this RS-232 standard. Now let's see the applications of RS-232 communication. RS-232 serial communication is used in old generation PCs for connecting the peripheral device like mouse, printers, modem, etc. Nowadays, RS-232 is replaced by advanced USB. Okay, USB stands for Universal Serial Bus. It is also used in PLC machines, CNC machines, and servo controllers because it is far cheaper. Its cost is very low, hence it is used in the heavy machines like PLC machines, CLC machines, servo controllers, etc. It is still used by some microcontroller boards, receipt printers, point of sale systems, that means POS systems, etc. I hope you all understand the RS-232 standard used for the communication in 8051 microcontroller. Thank you.